Today, I'm going to show you how to use all of the input ports on the terrain texture node to add more control to your terrain materials. Let's go! Alright, so we're in the middle of a series of videos on creating terrain shaders and materials. And in episode 2 of our terrain shaders and materials series, we created this simple subgraph in Unity to create a layer of terrain. So if we take a look at our terrain, you can see that I've got this dirt layer here. It's called dry soil. And if I select that layer and scroll down, you can see that the layer itself has a whole bunch of different settings that I can change, supposedly, in order to influence what that layer is going to look like. Now, using all of these parameters here assumes that you're also using the default terrain shader. And in fact, I'm not. I'm using a custom shader that we built in this series. And so in order for all of these parameters that are part of a terrain layer to work, we actually have to implement them in the shader itself. So that's what we're going to do today. I'm going to show you how to implement these parameters so that you can use your own terrain shaders instead of the one that's built in. Now, in episode 2 of this series, we built this simple subgraph that I showed you just a minute ago. And what I explained was I was leaving out the implementation of these parameters here to make the terrain layer more efficient. Here in our parameters, we have a color texture, a normal map, and a mask map. And what I showed you in episode 2 was how to pack all of this information into just 2 textures instead of 3, so that the layer would render more efficiently. And then I also mentioned that I was leaving out support for some of these other parameters so that we could make this layer render faster. Well, what I'm going to do today is go back and show you how to go ahead and add in these extra controls. And it will slow things down a bit, but I want you to understand what all of these input ports are for and how you can use them if you want to build the full implementation of what Unity intends for a layer to allow you to do with all of these exposed parameters. So let's go ahead and get started. The main purpose for this terrain texture node here is this first output port called texture. And that will output a texture asset based on which of the selections you choose here. So I'm going to choose diffuse map. And now this output port will be outputting the diffuse texture here that shows up when I select this layer. And our implementation has already used that. So here is our terrain texture output. And it's outputting the diffuse map you can see here. And then we use the split texture transform to split off just the texture asset and also the tiling and offset pieces of data here. Then we pass the tiling and offset into a tiling and offset node to set up the UV coordinates for our texture. And then we sample our texture here. You can see that the texture object is coming out of our terrain texture, going through the split texture transform node, and then out to our texture sampler node. So there we're sampling our color texture. So that's what this first pin does. It outputs a texture, and the textures that you can output are available here: the diffuse map, the normal map, the mask map, and the layer masks and holes. So those are the maps that you can potentially output from this first output port here. Okay, the next output is called available. And this output is an interesting one because it only actually applies to the mask map selection. So if I choose to output the mask texture, this output is a Boolean, and it's going to tell me whether or not the user has filled in the texture here for the mask map. So if no mask map is there, the available port is going to output false. And if the texture has been filled in here, it's going to output true. Now, in our case, we just have a color map and a normal map, and we're packing the maps that would normally go into this mask map into other channels. We put the smoothness in the alpha channel of our color, and we put the occlusion and height into the blue channel and the alpha channel of our normal map. So we're not using that third texture. And so that available output port there on our terrain texture node is not very useful for the scheme that I've chosen to use in this particular implementation of a layer subgraph. But what I want to do is show you how we could use this available pin if we were using a mask map texture. So let's go ahead and do that. So I'm going to set my terrain texture node here to mask map. And then I'm going to pull this out here, and I'm going to add a split texture transform here to split off the texture coordinates from the texture asset itself. And then we're going to sample that texture asset. So I'm just going to add a sample texture 2D node, and we're going to plug the texture asset into there. Now for the UV coordinates, we can use the same ones that we've already calculated up here with our tiling and offset node. So I'm just going to plug that directly into our UV coordinates. So this is our mask map. And so it has the channels here packed in a specific order. First, we have the metallic map coming out of red. Then we have the occlusion map coming out of green. Then we have the height map coming out of blue, and we have the smoothness coming out of alpha. Now, the next part that we need to implement is if I come over here and I add a mask map texture in this slot, what we do, what it exposes when I have a map there is these channel remapping options. So I'm able to adjust the metallic, the AO, and the smoothness with these sliders. And so what I want to show you next is how to implement that in the shader. So our terrain texture node has channel remapping offset and channel remapping scale output parameters. And in order to implement these little sliders over here, all I need to do is take the RGBA output of my mask map texture sampler, and I need to multiply it by the channel remapping scale. And then I just need to take the result of that and add the channel remapping offset. And then finally, I need to add one more node here, and that's a saturate. And once I've added these three nodes and used these two output parameters, now I can use the metallic AO and smoothness adjusters here to adjust the texture data that's coming out of my mask map sampler. Okay, and I talked about using the available node here, and that's what we're going to do next. So next we need to add a branch node. And this is the result that we're going to use if the texture available is true. So here's my available output coming out of my terrain texture node. And I'm going to plug that into the predicate of my branch node. And then if that available output is true, we're going to pass it the data that I'm getting from sampling my mask map texture. But if it's false, we need to set up some default values for metallic AO, smoothness, and height. So that's the next thing that we're going to do. So we need to create a combine node here, and it's going to create an RGBA value that we can plug into false. That's going to give us the default values for metallic AO, smoothness, and height. So for my metallic default, that one's really easy. I can just come over here to my terrain texture node and grab the metallic default and plug it in just like that. And the same thing is true for the smoothness default. I can just grab that and plug it into the alpha of my combine node. So now I've passed in my default value for metallic and my default value for smoothness. And if I don't have a mask map texture, I can just put a value of 1 for height here. But for the ambient occlusion, I'm going to do something just a little bit different. I'm going to take this channel remap offset value, and I'm going to grab the green channel out of here. So we're going to use a split, and I'm going to use this green channel output. And I'm going to add that green channel together with the green channel that's coming out of my channel remap scale. So I'm going to take both of those green channels and add them together. And that's going to give me, and then I want to saturate the result as well. And that's going to give me the default value that I want to use for my input green channel here, which is my ambient occlusion. Okay, so you can see now that I'm passing in my metallic default, my smoothness default, and my ambient occlusion default. And those are just kind of like hard-coded values that I can use if I don't have a mask map texture available. Okay, so that is how I use my available output port, my metallic default, my smoothness default, and also the channel remapping offset and channel remapping scale values to control the values that I normally get from the mask map texture. All right, the next port that we have here is called normal scale. And there are two different ways that I can use this value. Typically, if I have a normal map and I want to control the strength of that normal map, which is what this normal scale value is doing here, I can just add a normal strength node and pass that normal scale output into the strength input port, and then pass my normal in here, and that will allow me to use this normal scale parameter to control the normal. But that's not what we're going to do today. We're going to do this a little bit differently. So here is my original subgraph that we created again in episode 2. And by the way, if you haven't seen episode 2 yet, be sure to go back in the playlist that I'll link down in the description below and watch episode 2, because that's where we build this part of the shader. So what we've done here is we've taken the X and the Y of the normal and used a combine vector node to combine those together. Then we used an expand vector 2 node to multiply by 2 and subtract 1. And that expands the output range of our vector to the -1 to 1 range. And then we're using an append node to add a third component. And we've done this little optimization where instead of using a square root operation to calculate the third component of our normal, we're just giving it a hard-coded value of 0.5. And we talked about what a nice optimization this is, because it skips a bunch of calculations that would otherwise be, just a little bit expensive. So this makes our shader a bit more cheap. And the lower we go with this value that we're appending, the stronger our normal is going to be. So if we give it a value of 1, around 1, we'll get a normal that is like the normal strength value. But the lower this value goes, the stronger our normal will be. So what we need to do is take the output that we're getting from our normal scale here, and we need to add a lerp. So there's our lerp value. And now what we need to do is lerp between 2 and 1 using our normal scale input here. So normal scale is the T value for our lerp, and we're lerping between 2 and 1. And then we can plug that into our append, and then that will determine the strength of our normal. And so this allows us to use this normal scale value to control the strength. And let's go ahead and hook this up and just watch what it does. So I'm going to save this. And now we can switch over to our scene here and adjust our normal scale value. So I'm going to set it to 0. And you can see that our normal has been reduced significantly. But if we set it to 1, now it's kind of a normal strength. And if we set it to 2, it's going to be really, really crunchy. And so we probably want to set it to something like 1.3 or 1.5, just to give us a little bit of normal map strength. But you can see here that now that we have these hooked up, we can use that parameter to control the strength of our normal map. We can also use the size and offset values here to control the tiling of our map. So the higher we go with these values, the bigger our terrain texture is going to appear. And the smaller we go with these values, the smaller and tighter it's going to be tiling. Well, there's another value here called color tint that we haven't used yet. So let's switch back to our shader. And here you can see our terrain texture node has a color tint output. And actually, you know what? It makes a little bit more sense to use this version of the terrain texture node. So I'm just going to open this one up and just kind of move these nodes around to give us a little bit more space. And here we can take the color tint coming out of here and multiply it by the color texture that we're calculating. So here's our color texture sampler. And all I have to do is take the value coming out of here and multiply it by our color texture. So I can just pass our color texture in here and then pass it out to color here and also color there. And now when we come back over here to our scene, I can modify our color value here and use it to tint our terrain. So if I want to make our terrain just a little bit more yellow-orange, I can do that really quickly with this color tint parameter. All right, so we've implemented color tint, we implemented our normal map scale, and we implemented our channel remapping. Now, there was one thing with the channel remapping here. I didn't actually show you how to do this in our case because we're using the 2 texture solution instead of 3 textures for our terrain. So let's go ahead and do that. So what we need to do here is give ourselves a little bit more space, and we need to take the values that are coming out of our 2 texture solution. Here, let me just move these nodes out of the way to make it a little bit more simple. So we have our smoothness coming out of the alpha channel of our color. And so we can add a combine node here. So we're going to put our smoothness in the alpha channel. We're not using metallic, and so I'm just going to leave that one as 0. But we are using ambient occlusion, and the ambient occlusion is coming from the blue channel. And so we'll plug our ambient occlusion into there, and our height is coming from the alpha channel, so we'll plug that into B. And now we've packed our values into our combine. And so all we need to do now is take this and multiply it by our terrain texture values. So we have channel remapping offset coming out of here. And so we need to multiply that by our RGBA value. And then we need to add our... Oh, whoops, I used the wrong value. That's our offset. We need to multiply by our scale. And then we need to add our offset. And so once we've made those adjustments, now we can split this out again. And we can plug the metallic into metallic. We can plug the occlusion into our occlusion. We can plug the height into our height, and we can plug the smoothness into our smoothness. And so now we can use these adjustment values here to adjust the smoothness and occlusion of our terrain. So if we take our occlusion value, we can adjust it using our sliders, and we can also adjust our smoothness. You can see it's getting much smoother as I crank that up, or I can make it less smooth as I bring that down. So that allows us to use our channel remapping sliders in our material. All right, so we hooked up our color tint, our normal scale, our channel remapping, and our tiling settings. And we have all of the parameters here that are normally available for the default Unity material in our layer. And we've done it in a way that preserves our simple 2-texture solution to make this less expensive. Now, like I said at the beginning of the video, these additions, make our material a little bit more expensive. So if we wanted to make this cheap, we could skip our diffuse texture tint here that we're doing. We could skip our normal map strength here that we're doing. And we could skip implementing our channel remapping here that we're doing as well. And skipping these would make our layer just a little bit cheaper, make the shader have to do more math. But what you have to decide is, do I want to give myself these parameters that let me tweak things in real time or have more control? Or do I want to adjust these kinds of values in the textures themselves instead, which takes a little bit more development time, but it also means that we can skip the math that's required to implement these and make our layer shader just a little bit cheaper. So it's really up to you to decide, is it worth the extra cost for me to implement these adjustment parameters, or do I want to try to make this layer implementation as fast and as cheap as possible and just leave these out so that I can't tweak these parameters in real time? That's up to you. Do I want to make it as fast as possible, or do I want to make it a little bit more flexible and easy to adjust? Anyway, so that is our video for today. We've gone over all of the input ports here on the output ports here on the terrain texture node, and I've explained to you how to implement these so that you're bringing in the values that are available here on the material control panel for each of the individual layers to allow you to adjust those layers. I hope this was useful to you. If it was, or if you have a question, let me know down in the description. And otherwise, thanks a lot for watching, everybody, and we'll see you next week.